Page 5, number 22. What is the area of the circular base of the fire cone? Round your answer to the nearest hundredth. So we're rounding to our nearest hundredth, and the ask of the question is, what is the area of the circular base to this fire cone? So area of the circular base, that's your goal. Now, even though this is a three-dimensional object, the only thing they care about is finding the area of just the base, which we know is the shape of a circle. So our end goal is going to be to find the area of that circle. So I'm going to write down area of a circle, which we should all know. It's going to be pi r squared. It's part of every volume and surface area formula that you need to know. Okay, so now let's take a look. We just need the radius. Now, looking at your fire cone, you don't have the radius. So the radius would be right around here, and you don't have it. Now, you may recall that with things that have a big point at the top, for example, pyramids and cones, you can find some triangles inside of there that could help you solve for whatever's missing. So right triangles are some of our best friends in geometry because we could use Pythagorean Theorem, we could use trig, we could use special rights, we could do all this stuff if we can just have a right triangle. Now, in this figure, you will end up finding a right triangle that will help you solve for the radius. Let's take a look at where you're going to find that right triangle. If I take this 28.7-inch height that's shown on the outside of the cone, and then I draw it on the inside of the cone like this, and I make sure I draw that it's perpendicular. So let me zoom in. I'll draw that it is perpendicular. Now you should see that a right triangle is formed. And that height, that red height that I just drew in, that's 28.7 inches. So if we have a right triangle, we could probably use either trig or Pythagorean theorem. We could use something. So let's take a look, break that triangle out, redraw it, and see what can we do to solve for the radius so that then we can go ahead and get our area for the base. Let's take a look. Here is my right triangle. I have 28.7 for the height. I have 32.1 for my hypotenuse, and my goal is to solve for r. Now, we can't use trig because we don't have an angle. So our better choice here with this right triangle is Pythagorean theorem. Now, Pythagorean theorem is a squared plus b squared equals c squared. C is always across from the right angle, so your C is the 32.1. You're not solving for C, you have it. What you're going to solve for is one of the sides, A or B. Now, you can decide which one to call A and which one to call B. I'm going to make a decision. I'm going to call 28.7 my A, and then the radius will be the B value. Let's plug everything in, and let's solve for that radius. I'm going to start. A squared is my 28.7 squared plus my B, well, that's what I'm looking for. That's the radius, squared, equals C is 32.1 squared. And now let's go ahead and square it in the calculator and solve. 28.7 squared. All right, so we're going to be dealing with a lot of decimals here. 823.69 plus r squared equals 32.1 squared, which is 1030.41. Now we need to get r squared by itself, so we're going to subtract 823 from both sides. 823.69, subtract 823.69. And in the calculator, I still have that 1030, so I'm going to click minus 823.69 0.69 equals. So now I have r squared equals 206.72. Now I don't want the radius squared, I want the radius. So I'm going to take the square root of both sides, and now I'm going to get the radius is equal to, let's go to my calculator, click square root. Well, it's not a very pretty number. 14.3778, and it's going to keep going. Well, I'm going to keep it in the calculator, so hopefully I can still get the exact value. So I'm going to move on over. Now that I have the radius, which was the entire goal of doing the Pythagorean theorem, I can go ahead and try to get the final answer. The final answer is just the area of that circle. It's just pi r squared. So let me go ahead and plug everything in. So now I have area of the circle, which is my goal, equals pi, then my radius of 14.3778 squared. Luckily, it's still in my calculator. So I'm going to start by squaring it. And there we go. Oh, it's back to 206.72. That makes sense. When I solved for r squared and got 206.72, that's exactly what I needed for my formula. So I didn't even have to square root it. But it's good that we went through this process. So back to it. We just squared that 14, so we have area of the circle equals 206.72 pi. And now we're going to multiply the pi in because I want our final answer to the nearest hundredth. So times pi equals, so now area of the circular base is 649 point, nearest hundredth, so 43, that's 2 decimals, inches squared. Let's go ahead and write this answer in. .43 inches squared. Jazzing it up with a cool color. All right, let's move on to the next question. Number 23, calculator question. Read it, come back. Okay, Tom Brady is playing basketball with his son. Thank you, don't care, let's keep it moving. He has inflated a basketball 14 inches in diameter. Okay, 14 inches in diameter. I know they gave me the diameter, but you should know we never use it. We always use the radius. So right away, I'm going to write down that my radius is half of 14. So my radius is 7 inches. With 750 cubic inches of air. So let me go back. He's inflated the basketball with 750 cubic inches of air. Okay, so that's how much air he's put inside of his basketball so far. How much more air to the nearest tenth, that's how we're rounding, can Tom Brady pump into the basketball before it's fully inflated? So fully inflated, meaning the full volume of the sphere, which that's what the basketball is, it's a sphere, the full volume is not 750. So what we need to think about is, well, what is the full volume? Because right now he only put 750 cubic inches in. Now, the reason we're thinking volume is a couple of things. First, when you put something into something else, you're talking volume. Volume is things that go inside. So capacity, something that needs to fit into something else, or air in this case. But the other piece that really clued me out to the fact that I'm going to be doing volume is cubic inches. Whenever units are to the third power, I'm thinking volume. So we're going to be talking about volume here. Volume. Now, if we can figure out the volume of the basketball, if it's full, and then we subtract how much is already in there, so how much air he's already pumped in, so the volume of how much he's already pumped, so the volume of maybe what it is now, right? Really, it's that 750. then what we're left with after we subtract how much he's already pumped into there is how much more air can fit inside. So what we're left with is the volume of how much more. The volume of how, try this again. The volume of how much more. Okay, so this is our game plan. We have the volume now. He said it's 750. That's how much we've already put in there. We're trying to figure out how much more, but we still need to figure out what's the full and total volume. What's the maximum that the sphere can hold in terms of the air? So let's pull out our volume formula for a sphere. Volume equals 4/3 pi r cubed. Volume equals 4/3 pi. Plug in your radius of 7 cubed. Let's go to our calculator. We're going to be doing the 7 cubed, and then we're going to multiply by 4 and then divide by 3. Not going to multiply pi in just yet. So 7 to the 3rd power. I have to hit second, and then the x to the 3rd pops up. So 343 is 7 cubed times 4 is 1,372. And then I divide by 3 all the way at the end. Divided by 3 equals. Okay, so we have approximately 457.3 repeating pi, because I haven't multiplied pi in. Now I need to think, should I multiply pi in? Well, let me take a look at what I'm going to be subtracting. If I'm subtracting a regular number that doesn't have a pi, then I don't want to keep this in terms of pi. I want to multiply it in, because it doesn't help me by keeping the pi when 750 doesn't have the pi. So let's multiply pi in. Times pi equals, so about 1,436.7, let's go 550 out 4 decimal places, because it's not our final answer yet. So on the left-hand side here, I'm going to plug in the full maximum volume of air that this basketball can hold, which is 1,436.755, and just trying to make that 0 fit in there. Okay, it's still in the calculator, so now I'm going to subtract the 750 that's already in that basketball, and we're left with 686.7550, yada yada. Our goal is to get it to the nearest, let's say, nearest 10th. Okay, so to the nearest 10th, the 7 needs to round up to 8. So our answer is going to be 686.8 cubic inches of air. So inches to the 3rd power. This is my final answer. This is what goes into this little box or underline. Okay, let's move on to number 24. Number 24. The line segment AB is partitioned by point J in a ratio of 1 to 3. What is the y coordinate of J? So pay attention, they're only going to ask you for the y coordinate. We're going to, however, do both the x and the y coordinate, because it's great to test whether or not your answer makes sense. So I'm going to do the whole thing, get both x and y. Now, this is a partitioning question. This is one of those formulas that you have to memorize. So make sure that after we write this down, you put it on the back of your reference sheet. So our formula is xp equals x1 plus k times x2 minus x1. And then you repeat that again with the y's. Now, before we start, this is what I always tell my students to do. We're going to start by sketching out the line segment. I know you have a visual, but a sketch is a little bit different. So we're going to sketch it out. Here's what we're going to do. I'm going to zoom in. I'm going to draw my line segment. Try and make it a little funky and cool. Put it with this cool color. And I'm going to call it AB, just like it's called. It's a directed line segment, so A is always going to be written on the left when I draw my little sketch here. Now I'm going to label in the points. So my points are -8, 5. My other point is 8, 3, and I'm getting that from the graph. And my first point A is going to be x1, y1, because my first point. And then B is x2, y2. It does matter which one you call point 1 and point 2. So make sure when they list out the name of the line segment, whatever letter they list first, you make sure you call it x1, y1. Okay, now the other point that we're going to put down is J. So J is going to partition the line segment, which means kind of split it, in a 1:3 ratio. So I'm going to put J obviously closer to A. So this is J. And it's going to divide it in a 1:3 ratio. So 1 on the left, 3 on the right, because that's how they stated it. 1 on the left, 3 on the right. Now, you care about this thing called K, which is a fraction. A fraction that tells you how far AJ is compared to the entire line segment from A to B. So when you go from A to J, you've covered one piece out of a total of 4 pieces, because you're going to add 1 and 3 together. So a total of 4. So 1/4 is going to be your K value. We're going to plug everything in, and we're going to solve for the partitioning point's X value, meaning the X coordinate of your point J. Let's plug everything in. So XP is what we're going to solve for. X1 is -8 plus 1/4 parentheses 8 minus -8. Make sure you write the minus before then looking at x1, because you'll notice as a result there's 2 negatives, which makes a positive. XP equals -8 plus 1/4 times 8 plus 8 is 16. XP equals -8 plus, when you have 1/4 times a whole number, what you can do here is multiply 1 times the 16, which is 16, and then divide by that denominator of 4. So 1 times 16 is 16, then divide by 4, and you get 4. -8 plus 4 means XP is -4. Looking at your graph, if I find where -4 is on here, it looks like when I'm touching the line segment, it would end up being at -4, -3. That's where it looks like J should end up. So I think my answer is going to be -3 for the y coordinate. But let's go ahead and do the formula and make sure we get the same answer. Okay, I'm going to zoom out a little bit here, slide on over. Okay, so repeating the same thing for y. This is maybe when you want to try by yourselves. YP equals y1 plus k times y2 minus y1. YP is what we're solving for. Y1 is 5 plus k is 1/4. That does not change. Y2 is 3 minus, and then y1 is 5. Okay. Oh, I noticed my own mistake. The y1 is negative, and I didn't write that down. Okay, good thing I caught that. All right, so it's going to be 3. Let me try one more time right here. It's going to be 3 minus a -5. Okay, double negatives again becomes a positive. So let's keep going. YP equals 5 plus 1/4 parentheses 3 plus 5, which is 8. YP equals 5 plus, okay, 1 times 8 is 8. 8 divided by 4 is 2. So 5 plus 4 is 2. Okay, let's keep going. YP equals 7. Now that seems wrong because we got -3. Oh, don't you remember we fixed the y1, but we didn't fix it in both spots. This is why graphing is so helpful, because if I had gone to my graph and I put down that it was at 7, which is all the way up here, I should have asked myself, well, that doesn't make sense. That's not even on the line segment. This is why graphing is so, so, so important. So let's go back and let's fix our own work. Let's find our mistakes and fix our work. So we have a -5 for y1. That's where we made a mistake. So this is a negative. So then -5 plus 2. That doesn't give me 7. -5 plus 2 is -3. Aha! That looks much better. Let's go back to our graph. So -4, -3 for j. I like that. Now, one thing I want to show you here is if I think about dividing this line segment into 4 even sections, I'm going up 2 and right 1, 2, 3, 4. If I go up 2 and over 4 again, I end up here. Up 2, over 4 again, I end up here. Up 2, over 4 again, I end up back at B. Now notice, by putting these other points in there, I've cut up my line segment into 4 even sections. This is my first section, my second, my third, and my fourth. So it makes sense that J, which is right here, divided my line segment, partitioned my line segment in a 1:3 ratio because there was 3 even sections to the right of J. So let's go back. Let's put our final answer. Remember that we did a little bit more work than we needed to. So our final answer is not both coordinates. It's not -4, -3. It's just the y coordinate. So our answer is just -3. Okay, let's move on. Number 25. Triangle ABC is transformed. Which transformation below will not always allow the statement AB is congruent to A prime B prime to be true? Okay, so basically we're asked which one will not be true that AB is congruent to A prime B prime. Well, when is AB not congruent to A prime B prime? Well, whenever a transformation changes the size of something. So you need to think to yourself, okay, I need to think, when are things not congruent? Which transformation would that be? And the answer is dilations. Dilations are your only transformations that are going to change the size of your object. Dilations are unique. They have a scale factor, and they're the only ones that multiply your coordinates by something other than 1 or -1. So dilations are usually like this. XY becomes KX. Let me change that. It looks a little messy. So usually it looks like X comma Y becomes K times X comma K times Y. And K is that scale factor, and it's usually the same exact number. Now let's take a look at our choices and see which one of these would be a dilation. Now the first one, I'm going to zoom in on this. The first one says X plus 4 comma Y. This is a translation. Translation. It's a translation or a slide 4 to the right. Not up or down, just to the right. B, -X, -Y. Now here's what I recommend. Try a triangle, put it on a graph, perform that transformation. It says change the coordinate sign of both X and Y and see what happens. If you do that, you'll see that this is a rotation of 180 degrees. Your figure will look like it went upside down. Look at C. XY becomes 4X and 4Y. It's multiplying. It's the only one that multiplies by some number other than 1 or -1. This is our dilation. It's a dilation with a scale factor of 4. So your figure is going to become 4 times as large and 4 times further from the origin, all those points. And let's just check the last one, D. XY becomes Y negative X. Now again, if you plotted something and followed this rule, you would see it's also a rotation. It's a rotation of 270 degrees counterclockwise or 90 degrees clockwise, because we know those are going to be equivalent rotations. Okay, let's move on. Number 26, calculator question. Now I'm going to give you a heads up. This is one of the trickiest questions in this packet, so I'm going to take it step by step. Mr. and Mrs. Smith share a love of coffee. Thank you, but not relevant to the problem. In the morning, Mr. Smith makes a large pot of coffee and splits it evenly between their two uniquely sized mugs. Okay, so we're talking about some mugs here. Other than knowing that it's in the morning and that he likes to share, that's not really very helpful. The mugs are cylinders that hold the same volume of coffee. Okay, I care about this. All right, they're both cylinders that hold the same volume, so their volumes are the same. That's important. Mr. Smith drinks from a mug with a circumference of 4.8 pi inches and a height of 8.4 inches, while Mrs. Smith's mug is much wider and has a circumference of 7.4 pi inches, but it's shorter. They didn't tell me how much shorter, but okay. What is the height of Mrs. Smith's coffee mug to the nearest hundredth of an inch? So that's where it is. That's why they didn't tell us. They're asking us for that. Now think about it. They gave you circumference, they talked to you about volume, and now they're asking you for height. Now this is going to be another instance where you have to work backwards. Well, let's get a visual going. I'm very visual. Most of us are. So let's start drawing something. I'm going to draw a mug for Mr. Smith and a mug for Mrs. Smith. So this is where I'm Picasso. Okay, Picasso's coming out. So it's a cylinder. That's not very good. Let's try this again. Here we go. Okay, so let's say this is Mr. Smith's mug. And then Mrs. Smith, they said hers is much wider. It's not as tall. They said it's shorter. So it's going to be Mrs. Smith's mug. I like to drink out of wide mugs too. Okay, let's put in some other information they told us. So Mr. Smith's mug, they said 4.8 pi inches in circumference. Well, that's not really a radius or anything. That's a circumference. So probably going to have to do some work with that. And then Mrs. Smith's circumference is 7.4 pi. Okay, and both of these are in inches, so I like that. It's the same unit of measurement. In fact, the height is even in inches, and they want the answer in the nearest hundredth of an inch, so good thing they're all in the same unit of measurement. Okay, let's label in the height that Mr. Smith's mug is. They said 8.4, so I'm going to put in 8.4. Okay, the other thing they told us that was important is that their volumes are the same. So this volume is equal to this volume. They didn't tell me what it is, but they said it was equal. And my goal is to get the height. That's the goal. Okay, well, I'm going to have to work backwards with this one here so that I can figure out the height. But I don't really have much. I have a circumference, but circumference doesn't use height. And I don't have the volume. So what you're going to have to do is start looking at Mr. Smith's mug and thinking about, well, can I get the volume of Mr. Smith's mug? And then I'll end up having the volume of Mrs. Smith's mug. Okay, so let's focus on volume for right now. Now, volume. I'm going to write down the formula since it's a cylinder. It's big BH, but big B is the area of the circle. So I'm going to put pi R squared H. That's the volume formula for Mr. Smith's mug. Okay, I have the height, so that's good. But what I don't have is the radius. So you know what I'm going to have to do is I'm going to have to take a look at the circumference and see, can the circumference tell me my radius here for Mr. Smith's mug? Think about what the circumference formula is. Circumference equals 2 pi r. So I do have the circumference, that's 4.8 pi, and that's supposed to be 2 pi r. You know what? I'm going to have to go ahead and find the radius of Mr. Smith's mug so that I can then do the volume. It's a lot of steps here, but we can do it. So the pi's are going to cancel. If you have pi's on both sides, they end up canceling out. Then I need to divide by 2, and then I'll be left with just the radius. 4.8 divided by 2 is 2.4. That's the radius of Mr. Smith's mug. Well, now that I have that, I can get the volume. If I can get the volume, then I'll have Mrs. Smith's volume, and then I could figure out her height. Okay, let's go ahead and do it. Volume equals pi times 2.4 squared times the height of 8.4. Move down to give myself a little bit more work room. Okay. Now, calculator work. I'm not going to multiply in pi because I already know Mrs. Smith's mug is also going to use pi, and that probably will make it easier if I don't multiply it in. So 2.4 squared times 8.4 for the height gives me 48.384. So volume equals 48.384 pi. I haven't multiplied the pi in. Okay, so now that I have that volume, I could go ahead and write down that Mrs. Smith's volume is the same exact thing, 48.384 pi. Okay, well, that doesn't give me the height yet. Well, let me go ahead and write down my volume formula. Again, volume formula for Mrs. Smith's mug is going to be the same as Mr. Smith's mug. Pi r squared h. All right, well, let's see what I have. I do have the volume, and, well, I don't really have the radius, so I can't even solve for the height yet. Let me go ahead and get the radius, just like I got Mr. Smith's radius. So, radius for Mrs. Smith. We have her circumference, which again is 2 pi r. I'm going to plug in that the circumference is 7.4 pi equals 2 pi r. The pi's will cancel. Divide both sides by 2. Okay, 7.4 divided by 2. 3.7 is the radius of Mrs. Smith's mug. Okay, so let me go ahead and plug that in for r, and then I can solve for h. So, back to my volume formula. The volume of Mrs. Smith's mug is the same as Mr. Smith's, so I'm going to put in 48.384 pi equals pi. The radius here in Mrs. Smith's mug is 3.7 squared. And then the height, well, that's going to be our variable that we're looking for. Do some algebra. Cross out your pi's. Next, let's do a 3.7 squared. So it's still my calculator, 3.7, square it. I get 13.69. Okay, let's rewrite this. 48.384 equals 13.69h. All right, last step, divide by 13.69, and I'm going to have my height. So clear this out. I'm going to put 48.384 divided by 13.69 equals. Wow, that's a long, long decimal, but they wanted us to round to the nearest hundredth of an inch. So 3.53 is going to be my answer. 3.53 inches equals your height. Go ahead and put that in for your answer, and whew, that was a long one, but we're finally done. So remember, This was a working backwards problem, but you had to work backwards almost 3 times. First, you had to go ahead and solve for the volume of Mr. Smith's mug, which first meant you had to solve for the radius. Then once you got the volume of Mr. Smith's mug, you had to plug it in for the volume of Mrs. Smith's mug. But then for her volume, to work backwards and get h, we had to figure out the radius. And the radius we had to figure out by looking at her circumference and working that backwards and getting our 3.7. Once we had that, we plugged in our volume that we got from Mr. Smith, we plugged in our radius that we got from her circumference, and we solved for the height. It was a long process, but we're finally done. Moving on.